Leading operators have so far failed to provide sufficient connectivity for many remote places throughout the world. Recently, governments have either supported this or directed operators to cooperate in creating coverage. Despite these developments, new operational models may be needed to further increase the penetration of internet coverage. The establishment of local networks without the direct involvement of a national operators has become increasingly important in certain areas where operators see no business case. We call them local private network or micro operators. This means a village could run its own network to provide connectivity or connection in the area. This has to be done according to regulations and rules and depends heavily on the local availability of the spectrum. In remote areas, infrastructure construction may be supported by other bodies like private companies, governments, or international organizations. Cooperating with leading operators should be guaranteed. Micro operators who engage with the community have much higher chance of success because they consider their local needs and can leverage their infrastructure to reduce capital and operation costs to become profitable. The potential of the micro-operator concept has been partially illustrated by its successful deployment in Peru to improve rural connectivity. In this case, the micro-operator that deploys the network infrastructure and operates in rural areas is called the rural mobile infrastructure operator. Its infrastructure is interconnected to the mobile network operator's network core, and revenues are shared. Once lighter regulatory requirements for such local micro operators and supportive government regime is shown beneficial, and if more flexible frequency use would be allowed, unused spectrum in remote areas could be utilized. However, if this is not an internationally agreed process, the market would be so small, and devices would be expensive, unless new flexible low-cost radio platforms could be available. Flexible frequency use means that interference control must be automated rather than executed manually. The interference control in the spectrum, by the way. To ensure high quality of service for the provided services, the operators and the local community should be sufficiently skilled to maintain and repair the equipment used in the deployed technology. They should view learning digital technologies as pathways to better employment and well-being for the community. The whole microoperator ecosystem includes various aspects such as available frequencies, a new flexible frequency regulation utilizing unused spectrum in remote areas and allowing local operation, national roaming or alike solution to allow nationwide use of the service agreement, billing as system, maintenance and operation, finance models, dual use with the government such as healthcare and education, the coexistence and cooperation with leading operators. The radio spectrum is the lifeblood of the telecommunication market. The debate centers mainly on how this resource, despite being limited, naturally finite, can drive both urban and remote connectivity. Nowadays, radio spectrum is exclusively and statically allocated to different wireless services, leaving very limited spectrum for fixed frequency assignments. This has resulted in spectrum shortage resulting from outdated spectrum management policy rather than a physical scarcity. A more flexible spectrum usage is preferred in the future. waves and terahertz bands can provide large chunks of the spectrum required to meet the extremely high throughput demand in 6G. However, these bands are very sensitive to molecular observation and impose tight constraints in terms of line of sight or propagation. With very limited penetration capabilities, positive side, these, character, positive side, these characteristics make wave and terahertz bands perfect for opportunistic spectrum reuse. Future research efforts may focus on the harmonious coexisting of users because communications are short-range and highly directional, meaning interference can be contained by avoiding the transmit beams or simply by being located a few meters away from it. To attain this objective, novel beam management and power level coordination schemes need to be designed. Unfortunately, the flip side of using these bands is that the required infrastructure investment is quite significant, and the operators must make difficult trade-offs between coverage, capacity, and costs. For radio frequency-related issues, new and more flexible regulatory framework, new regulations, spectrum regulations, two innovative incentive mechanism to motivate the occupants to share their underutilized or unused spectrum. Three, adopting a new business models and regulatory proposals for spectrum access framework that are technically feasible and commercially affordable and support remote area connectivity. So new policy from the outdated policy we have now.